like to welcome everyone. This presentation is basically a joint presentation between CppCon and the Northwest C++ Users Group. How many people are from the local area? Okay, anybody not aware of the C++ Users Group in this area? Okay, okay. So for those of you who are not, basically it's the C++ user group organization in the Puget Sound area. We meet every third Wednesday on the Microsoft campus. The website's nwcpp.org, and we'll push out information through all that. If you want more information, you can catch me or a few other people will be in the notes and so forth. So with that, I'm going to go ahead and turn it over to Will and Mark talking about C++ cross-platform development from Microsoft.
All right, thanks. All right, so hi, thanks for having us. We're going to talk about cross-platform C++ development and some of the challenges that you'll face with it or that you are facing with it, and how you can use tools to help you surmount those challenges. My name is Mark Goodner.
Will here.
So we're from Microsoft. We're with the C++ team there. We both work on the IDE features for C++ and focused on cross-platform development. How many people here are doing cross-platform development? All right. And how many of you are targeting Windows? A little bit less, yeah. And Linux? Almost everybody. So what other platforms are you targeting? Mac? Mobile? Android? iOS? Okay.
Embedded.
Solaris. What? All right. That. All right. So first, I'll remind you, we're running a survey at CppCon here this week. There's a potential for someone to win a Xbox One S Starter Edition. This is handed out at the the Friday morning or Thursday morning? Thursday morning. Thursday morning at Herb's talk. So you have to be present to win when your name is pulled. So you have to take the survey, leave some contact info. Oh, I have to hit next? Oh, look at that, a build slide, crazy. So you have to be there to win, but go ahead and take the survey. That's the link up there at the top, or you can find us down at our booth anytime during the week. We also have other sessions going on at CppCon. You can see most of these sessions have already occurred since we're all the way here on Wednesday evening, but all of these are recorded so you can find them online. Particularly the one earlier today that kind of was a whirlwind tour on Visual Studio and what's new in Visual Studio. A lot of cross-platform stuff was shown there, but we're going to dive a little bit deeper into that. And then we have a few talks tomorrow as well. So first off, I think we kind of wanted to walk through things in this kind of a direction in terms of what the challenges with cross-platform C++ development were. We're kind of trying to think about how to talk about these in some kind of order. So first we're going to try and kind of go through libraries and compilers and the sort of things that you see there before moving on to build and testing. And then of course you've got debugging. And I kind of think the last two, I'm not sure how many of you think editing is actually a problem with cross-platform development? So not so many. So yeah, you kind of take that for granted. Is your host operating system actually a challenge when you're cross-platform developing? A little bit? Not a lot of hands on that one. Okay, all right. But libraries? Libraries? Yeah, libraries. Your compilers? Yeah, Yeah, that's what I thought, yeah. Debugging? Okay, all right, there's the one. All right, well let's talk about libraries and compilers first. So one of the things with libraries is that you've got these system package managers sometimes, and if you're on Linux, you definitely have system package managers like apt or pacman, etc. But the great thing about them is there's so many and you get to learn how to use all of them, right? It's fantastic. You get to write scripts to identify which version of Linux you're on and then guess which package manager to use. And hopefully it's not a new distro of Linux. And then there's other operating systems, like Windows and Mac that don't have a package manager at all. So you get to use third-party ones, and none of these package managers are really optimized around libraries, right? Like on Linux, you get libraries from the package managers, but they're really optimized for the operating system for the distro. they're lacking in terms of trying to find like maybe the latest version of a library that you're trying to find. But so one of the things you can do is you could manage your libraries from source, right? You can do that, and that gives you complete control, which is great. How many people think it's great that gives you complete control of managing libraries from source? Is that great?
No.
How many people think that's really challenging? Yeah, all right, yeah. And so, but there's a lot going on in the ecosystem, right? So there's a lot of things happening around package managers for C++. So we're going to show you some approaches to that with Vcpkg. And then compilers, today compilers are getting a lot more consistent with supporting the standards. I guess that's because MSPC is supporting the standards better, right? So we're getting better, but I know that in the real world you're not always targeting the latest version of Windows, right? You're probably supporting something that we don't.
Windows 95.
All right, I haven't heard that one in a while. No, we're not going to help you with 95. So in the real world, you are going to have to deal with differences in compilers, particularly as you're targeting older platforms where the newer compilers aren't targeting those yet. But when you come to build, it seems most CMake seems like it's becoming kind of the de facto build system for C++ these days. But it's really kind of this meta build system on top of other build systems. And what's so great about that is people are going more meta on top of CMake, right? So you build systems on top of the meta build system. And ideally, you'd have a CMake file that would have no platform-specific information in it, right? It would just tell the compilers how to work, where to get the libraries, what code you wanted to compile, and that'd be great. But that's not the real world. And a lot of projects that are using CMake that you find today, they have a whole bunch of stuff in them. There's a bunch of stuff that specifies specific compilers to use. Or there might be, even worse, a compiler assumed that it's being used instead of another one. And it has intrinsic flags or something for that compiler, and then when you build on another platform, now it doesn't work. Or there's platforms specified throughout it, right? You find, ifs around Unix or Linux or Windows or Mac all throughout these files. And then the other one is that and we've run into this recently in trying to look at some open source programs that we wanted to show using like Vcpkg with, but the projects predated the existence of Vcpkg or Conan or things like that, and so they had a bunch of logic within the CMake files of how to find these other the libraries that they used. And so that logic like actually defeated actually using Vcpkg with them, for example. So you had to actually change the CMake files to not do all these special things in order to let a newer tool actually do that job to help make these things more cross-platform. So it's kind of interesting when you try and apply these newer techniques to existing projects that have been out there for a long time, you find these sort of problems. And then of course you've got MS Build if you're targeting Windows. And it's only, MS Build is really only for C++ on Windows. And I say kinda there because we do have within Visual Studio there's support for targeting Linux from Visual Studio Solutions. But what it actually does is it drives, MS Build runs on the Windows PC to drive compilation remotely on Linux over an SSH tunnel. But that's MS Build driving GCC on a remote. So it's not, you can't take an MS Build project and actually, even though MS Build runs on Linux these days, how many people knew that? Do you know MS Build's available on Linux? A few people, okay. So MS Build actually is cross-platform now and does run on Linux, but it's not for C++ on Linux. I don't recommend that. It's really for the .NET ecosystem. It's more focused around enabling .NET Core, which is cross-platform. So the only C++ for Linux with MS Build is really from Windows driving a build on a remote Linux machine. And there's other ways, and a lot of times people are generating solution files from CMake on Windows to do their Windows builds, but you don't need to do that. I hope everybody's learning here that Visual Studio supports CMake natively. You can open a folder with just CMake and you can use that in Visual Studio. How many people here didn't know that? Okay. a few. Well, I hope you guys give it a try. Definitely give that a try. You can just clone your source, open the folder that has your CMake list.txt in it, and Visual Studio will light up and actually let you build your source there. And it not only will let you build that application natively there on Windows, we can use that same SSH pipeline to build that code base on Linux if that's what it's targeting. So you can actually use Visual Studio and switch configurations from Windows and Linux with a folder with just a CMake list.txt. And then of course you've got Make and all of the other things that are out there. You know, there's other emerging, newer build systems. How many people here are using Meson? Not so many. No, not a lot. Make, obviously everybody's using Make, right? Yeah. Do you want to stop using Make? Do you need a support group? I think the point here is that we have within Visual Studio and VS Code, there are also ways to use arbitrary build systems when we don't know what it is. The thing that CMake gives us is CMake actually gives us information from CMake server mode and the newer versions of CMake that gives Visual Studio or any IDE really information that it can use to provide IntelliSense and smarts about the compiler and what's going on in that build that can then be used within the tools. Older build systems like Make, you can't really extract that information out of them in any sort of deterministic way. And so that's why CMake is very popular for using in tooling scenarios like that. But there are of course newer things that might be able to provide that same sort of metadata, but that's work to enable, and so everything's focused around CMake within the ecosystem these days. If something else were to emerge, then of course you could look at adopting it. But what we have today is the ability to open a folder with any source code in it of C++ source code, and then through configuring some JSON files. If you saw Rong's talk earlier today, she showed cppproperties.json being used within the context of VS Code. And so with a little bit of configuration, you can actually get IntelliSense and some smarts about your code. You can tell the IDE, whether it's Visual Studio or VS Code, a little bit about your source base so that you can get IntelliSense within there. And so that's probably a good transition point to talk about what you can actually do. So Will, you want to give a demo here?
Yeah, so I'm going to be showing a quick cross-platform code base. If you were in Marion and Steve's earlier VS talk, it might seem a little bit familiar. It's the Pong demo.
Is this not on?
Yeah, I've got the green light. Yeah, good. Okay. Oops. So it's a cross-platform application. It runs on Windows and Linux. It's based on CMake, as a lot of cross-platform projects are these days. So it has a dependency on SFML. It's just a simple graphics library that allows us to have a common surface area across Linux and Windows to create windows and draw to the screen. So the first thing that we want to do if we're going to work with this project, and I'm going to start out showing how to work with it on just a Linux machine, so just getting up and started on the Linux side of things. How to work with this project, and the first thing we need to do is get our dependencies. So as Mark was saying, there are a couple of ways that you can go about doing that on Linux. The first one, of course, is just to use the system package manager. That has a few advantages, a few disadvantages, as Mark was saying. So it's easy if you know the system package manager for whatever your distro is. If you just type your apt install, you're going to pull down the development package of the library you need, and it will take care of all of the transitive dependencies of that library for you. Which is nice. The advantage is that's fairly easy to get up and running with. It'll normally play nicely with CMake. That's not always true. That can depend a little bit on the package. But the real disadvantage of that is you give up a lot of control when you're using the system package manager. If you have tried to do this, I'm sure you know. The most common way that this manifests itself is the development packages that travel with the system package manager, they tend to be fairly old. So if you want to get the latest and greatest version of the package to work with your project, that's probably not going to be the right way to go there. But there are also some other subtle, more subtle changes, subtle issues if you're using a system package manager around versioning and customizability. For instance, if you're building on top of the system package manager, it does have a tendency to change things underneath you because the system package manager is responsible for keeping the system up and running. It's not really there as a development system. You can use it that way, but that's not necessarily its primary goal. So it's possible that you'll pull in some dependency way up the chain that happens to change out the packages that you're developing against, and then that got updated. And now that many distros are actually running updates of the system, even without any input, that can sometimes just happen. And the way that manifests itself can be anywhere from, if you're lucky, it'll just keep working. If you're less lucky, it might cause some sort of linking error that you're not really sure where that came from while you're just trying to write your code. If you're really lucky, it'll cause something mysterious to fail at runtime, and then you'll get to diagnose why that didn't work. So system package managers, it's easy to get your dependency, all the transitive dependencies, but it has some other quirks. You give up a lot of control when you do that. So the alternative that I think a number of you in the audience have resorted to is going to actually build all of your dependencies from source code. And you get a lot of control with that. With great power comes great responsibility, because now you are in charge of figuring out the entire dependency tree for all of your libraries that you're pulling in. Even for this fairly simple demo that I'm showing here, this Pong demo, it has one dependency, but that one dependency itself, that SFML library, pulls in, I think, 5 other libraries in its transitive dependency tree. So that then requires you to go through and actually look through all the instructions for all of these transitive libraries. Like, it includes Vorbis and FreeType and a few other things to get all the graphics library up and running. So that can be fairly time consuming even for a simple project like this. That gets quite a bit worse in real world projects when you have many more dependencies, especially once you start ending up with things like diamonds in your build graphs, and then you start having to try to figure out, okay, does this dependency that these other dependencies are pulling in, is that actually working? Do I need to patch it to get these to all play nicely together? And what seems to end up happening fairly often is a small handful of people, or maybe even just one person, will actually understand how that whole dependency tree works for the project. They'll distill all that into some shell script that gets checked into the source tree, and then if something goes wrong, you get to spend an hour or so on your favorite chat program with the masters of this build system to try to figure out what didn't actually work. So those are 2 ways that have been around in the past for getting your dependencies, but what I wanted to show you here was how to get this up and running with Vcpkg. And Vcpkg tries to take a lot of the advantages that you get with all the customization and version and control over the versions of the packages that you're using with building from source with an actual system package manager. So I will show how you get started with that. Vcpkg is super easy to install. All you have to do is just to git clone. Microsoft Vcpkg. I don't have the network working on here, so I already have that, but I'll show you what that does. So once you have that down, Vcpkg, all you have to do at that point is run the bootstrap script, and that will pull down the remaining dependencies. To get Vcpkg up and running, the only dependencies that it actually has on the system are you need Git to pull down the original repo, and you need a working C++ toolchain, compiler and toolchain. So once you have that installed, and that the install is super quick, at that point you can actually start getting your dependencies installing your dependencies so that you can actually start working with them. So if we go here, SFML, super easy to pull down the list of packages that Vcpkg supports. I should note, this didn't actually have to go out and hit any server to do this. All of this information and metadata is in that repo that we just cloned. So all of the version information is going to be fixed. Nothing is going to change underneath you if you update anything on the system. And when we go to install this package, we're gonna get the version that we're actually locked to here, depending on what depending on what commit we've checked out of Vcpkg. That's kind of what sets all the versions here. So you might have noticed this was super quick. The way this normally works when you're cloning it for the first time, I've already installed this so that I don't have to fight with the network too much. This will pull down the sources for the packages that you need. It will go through the entire dependency tree. It will set all of that up for you, build it with the toolchain that is actually on the machine itself. And on this machine, installing SFML and its couple of transitive dependencies, it took about 3 minutes, so it's a fairly quick process. And once it's done, it will actually even tell you how to include this package in a CMake file. So if we now go to our demo program here, and I'll open the CMake list.txt. We can see basically it shows us our usage here, so we can pull all of the package, and then this is how we would link the libraries into our CMake list. And it's a lot shorter in the CMake list because we only need the graphics library out of this. And then, sorry, could you say that one more time?
Can you zoom in?
Yes. Just a moment.
Control plus.
Control plus. Ah, great. Is that good? Okay. So this is a pretty short CMake file, and I'll actually be coming back to this in a little bit to talk about some of the other advantages that you get if you're using a package manager like Vcpkg. So the next thing that we're going to want to do here is actually get this working with VS Code. And this library that I just installed here with Vcpkg, that has been installed into the Vcpkg tree itself. So it hasn't polluted the system root in any way. If you had multiple instances of Vcpkg, for instance, if they were pointing at different commits to get different versions of libraries, they won't interfere with each other in any way. Go ahead.
Is the install compiling from source, or is it downloading it?
It is compiling from source. And yep.
I don't understand how CMake finds this library if it isn't installed to system directory.
Good question. I will show you how that works in just a second. So we build from source, one, so that it's using the toolchain that's actually on the machine that you're running on. But also it does allow you to customize to a certain extent if you need to build the libraries in a different way. You can build it the way that works with your project instead of what the system package manager is dictating works well with that distro. So, and continuing off of the question that you just had, to get this working with an actual CMake file is very simple. Vcpkg, create install. So this command will just show us our toolchain file. All you have to do is drop that toolchain file on the CMake configuration. And if I can copy this. Okay. So So it's that simple. Once you put that toolchain file onto it and run CMake, Vcpkg takes care of everything for you. So it will make sure that it finds all the include directories, all the libraries to be linked into your code properly. So, and again, you can have multiple instances of this if you need to have different versions of things for different projects. So that's, the toolchain file is what allows you to actually find and build against a specific set of packages that you've installed in one of these Vcpkg environments. So now that we have that done, we should be able to build just by running make. And since the toolchain file that we just dropped on there has told it how to find, has basically told CMake where to go find the libraries and the include paths, everything just works there. And we can see we're up and running now from the command line, or on the command line on Linux. So far I've shown how Vcpkg is integrating with CMake, but that's not the only way you can do it. You don't necessarily have to use CMake with Vcpkg. If you're using another build system, it's fairly easy to wire it up. We have the toolchain file for CMake, but if you're using, say, Make or even your own build system, if you decided to write something from scratch or have some in-house system, all you have to do is get the include directory out of Vcpkg, the library directory, and the way that those are arranged are almost like a sysroot within a sysroot. So you should be able to just include a single include directory, a single library include directory to pull in all of your dependencies as long as you've installed them in that package. And then you just have to specify to the linker what it needs to pull in, and that all should just work. So this isn't just CMake. The integration is there for CMake, but you can get this working with other things as well. So that's how this is working on Linux without any IDEs. But the next thing that I want to show you is how this CMake is integrating with Visual Studio on Windows. So I'll back out of this for just a minute. Launch VS. So I'm going to open this Pong folder. It's exactly the same code that we had on that Linux command line that I just showed you there. So as Mark was saying, in case anyone isn't aware, as of Visual Studio 2017, you can just open a folder with CMake text files in it, or the CMake list.txt, and we'll automatically detect that and start configuring. So I've opened this repository here, and we got an error. That's to be expected. If I go here, the find package failed. That's failing because I haven't actually configured Vcpkg on Windows yet. So I can show you how easy it is to get that up and running. So I'm not actually going to show you how to configure Vcpkg on Windows because it's exactly the same as it is on Linux. So same flow, git clone, run the bootstrap script. This time it's PowerShell instead of Bash. That's pretty much the only difference. Vcpkg install, Vcpkg integrate install, and it'll give you the toolchain file that you need to drop into your CMake command line. So let me zoom in a little bit on this because I'm sure this is pretty small. Control plus, yeah. Great. So to get this connected to the Vcpkg install that I have on here, I need to create a configuration on here. That's going to create a CMake settings.json file. That's what Visual Studio uses to store its the command lines that it's passing off to CMake, and some other settings that can influence IntelliSense, any variables that you need to pass off to it. But for this purpose, it's pretty simple. I'll just grab an x86 debug configuration. And from the command line here, Control plus doesn't work on CMD.
No,
Sorry.
there are settings over there at the top left corner.
All right. Okay, well it worked. You know, what's a spurious error message now and then? CppCon, package. So I've already installed the SFML package. This will give us our toolchain file. For anyone doing MS Build development, I'm guessing that's probably not very many of you, given the topic of this talk. It also wired it up to work with MS Build projects on Windows, so now any VCX proj will find the packages that you've installed here. But we're more interested in this to get it working with CMake, so I'll just drop that here. Okay. And rebuild the cache here. So if any of you have tried to get a cross-platform application working on Windows before that probably started on Linux and had a number of dependencies that were coming from a Linux background, getting this working on Windows can be a real pain. A common way that you can end up doing it, if you're lucky, you might find binary distributions from some dubious origin that happen to be the right version and using the right compiler to be compatible with your project. But in the most common case, you're going to be building pretty much everything from source. You're probably going to be using build instructions that haven't been updated since Visual Studio 2005. It's usually pretty out of date when you're trying to get some of this stuff working on Linux. But if you're doing this with Vcpkg, you can just do your Vcpkg install, and it'll pull in your package, all the dependencies, exactly like you saw on Linux. Now if I go here, let me put a breakpoint in real quick on this. I'll debug this, and it should build, finds all of its packages, hit the breakpoint. So now if we want to, say, for instance, debug into one of those dependencies that we've built with Vcpkg, that should just work if we do a step into here. So this is going to be a little small, and unfortunately I don't have a way to zoom this in, but if you squint, you can actually see this header, or this C++ file that I've just stepped into, that's actually coming out of that Vcpkg directory. The toolchain wires up all of the, it'll find all of your headers. It builds the PDBs, so everything should debug pretty much just like you built everything from source and it was right there on disk. So if we continue here, it worked pretty much exactly like it did on Linux, and it's up and running. So before we get too much further, I did want to show you the CMake list file that's actually underpinning all of this. So this is the CMake file. It's pretty simple. This project has one source file, so it's not really doing anything especially complicated. But one thing that you might notice in this file is there aren't any Unix or any sort of platform-specific conditionals. So it has this find package, it has adding the target link libraries in. So those two lines work exactly the same way on Linux. They work on Windows. And that's all possible because of Vcpkg. So it lets you really simplify the way that these CMake files can look. So before we got this working with Vcpkg, the way that this looked, it actually had two if Unix. It would change the way that it was linking in its dependencies so that it could statically link them. Vcpkg does that for you. And it also pulled in a 300+ line helper CMake script that would help it find the SFML library on a variety of distros, and that had to be checked into source code control. And presumably, if you had a bunch of these on a bunch of different dependencies in a real-world project, that would start to be a real pain to manage those. If you update distros and stuff starts to break, you have to go through and actually update all of those manually. You'd have to update all of the all of the conditionals that you have in here manually to get it to find all of your packages across all of the platforms that you're actually trying to target. So I'm guessing in most of the real-world projects that you guys are actually working with, there probably are a lot of conditionals. Some of them are fine. It's to be expected if you're building with different compilers and different platform-specific logic. You're going to need to have some of these conditionals to bring in either platform-specific code or to make sure that the right flags are going for GCC versus MSVC if there are some subtle differences there that need to be worked out. But where you don't necessarily want to be thinking about that is to just find your dependencies. So Vcpkg should save you from having to do too much of that. However, if you do have a project that has a number of these conditionals in it and is bringing in all of these scripts to find dependencies, and you want to try out Vcpkg with it, you don't necessarily have to remove all of those. Vcpkg, once you include that toolchain, it does tend to do the right thing. It'll override things if it needs to. So if you want to try it out to get even just a few dependencies or the entire dependency tree for your project, having those conditionals, they shouldn't block you. And then if you end up, if Vcpkg is working well for you, you can slowly remove those if you end up deploying it out to make your build scripts look a little bit cleaner. So just wanted to show that real quick. And the next thing that I want to show you, so we built this from the command line on Linux, and that's great, but it's not necessarily the easiest to debug, and you could potentially wire it up to VS Code or any of the IDEs that work under Linux. But if you are already working on Windows and you want to potentially work on a cross-platform project, oh, go ahead.
So I'm just curious, it looks like Vcpkg, if they handle those conditionals for you, then what happens if you pass off your CMake list in your project to somebody who doesn't use Vcpkg? Wouldn't it just kind of transparently break?
So yes, if you take all of those out and give it to someone who isn't using Vcpkg, I don't believe it's going to find all of your dependencies. So yeah, that is a bit of a problem. Yeah?
Is it complex to configure the system to build in Visual Studio 2017 to use compiler for 2013? That's what we are doing right now on some project. It's complex to configure. So maybe CMake file or where should
So you're asking how to get CMake to build with the earlier Visual Studio toolsets. So you could probably accomplish that with a toolchain file. I'm not sure if we have an easy answer for that yet, but we should chat after the talk about how you're using it. We might be able to.
No, so such an easy way as just select Visual Studio of both previous toolsets.
Yeah, that's true. It's not quite as easy in CMake today as it is with VCXproj. In general, we're trying to get as many of the Visual Studio features for CMake, working for CMake, so that they're more or less at parity with the VCXproj. Pretty much every release that we've shipped is getting closer to that, but you should really definitely tell us what you need, and we'll try to prioritize that. So let us know. Yeah, we should chat after the talk. Yeah?
May I ask you to show toolchain file on Linux? Show toolchain file that you provide to make that shortcut hands.
Sure. Let me see that. Oh no, it's here. I actually have the. It's not. So I have the author of Vcpkg here. Maybe we should. We can chat after the talk. Let's do that.
Okay. One question.
Yeah. Cross compilation. So we don't have support for cross compiling yet. We have support for targeting Linux, but it builds it on the machine itself.
But let's say Android or Emscripten, the browser. Existing cross-compilation toolchains for Windows.
So if you have a toolchain file that gets the cross-compilation working from the command line, you should be able to use it in Visual Studio. I'm not going to sign up for that working for everything just yet, but I'd like to hear more about it, so we should chat. Yeah.
Real fast.
Yeah.
The 2013 tool set in 2017, there's just a -t command for CMake, and you can just pass it a tool chain.
Okay.
Yeah. It's real nice.
Yeah.
But we can't use toolchain.
You should be able to specify as many toolchain files to it as you want. Oh. Okay. So if it's just a command line variable to CMake, you should just be able to specify it right here. Did you say -t? So that's probably where you would put it. So just
show us a toolchain file. See what they look like. It would help if you'd actually show us a toolchain file. I mean, I know what they look like, but if you're not in CMake deeply, what does a toolchain file look like?
So a toolchain file it's basically just a bunch of CMake script. If you want to see this specific one, it is in the Vcpkg repo. But yeah, we can. I'm going to move on for now, but yeah, we can chat about it afterwards if you are interested. Okay, so we have this working on Linux. So the next thing that we have this working for Windows. The next thing that I wanted to show was how you can actually get this to target Linux. So from Visual Studio, if you're already in Windows, you might you can basically, without having to spin up another IDE or anything else, or actually go to the machine, you can target it directly from Visual Studio itself. So to do that, you can just add another configuration here. Add configuration. So this is adding it to that same file that we touched before. Linux debug. That added it there. The only thing we have to do here is we have to tell it where to find the Vcpkg toolchain file on Linux. And remember, this is a remote path because the build is happening on the remote machine itself. It's not cross-compiling. So if I pull this in, our CMake commands, and switch to the Linux configuration, it should contact the remote machine, and yep, it's started configuring. So let me show you how that actually works on here. If we go over here to the, let's see, oops, to the cross-platform connection manager. So this is just in tools options, cross-platform connection manager. It's really easy to add a connection to a remote Linux machine. You can just click add here. Basically, the only prerequisites that you need on that remote machine are a recent-ish SSH server, and if you have rsync installed, it will speed up a few of the file transfers as well. So the one tricky bit that you need to get this working with CMake today is you need a fairly recent version of CMake on the remote machine that you're targeting. If you're not using CMake, all you need is SSH. But if you are targeting CMake, I think it's CMake 3.9, and that's more recent than a fair number of system package managers.
Yeah, and actually, with the first time you try and connect to CMake with Visual Studio, if you do not have CMake configured, or if you have an older version of CMake, it will give you an error message in the output window with a link on where you can go to get instructions on how to set up a recent version. And we even have a universal build of CMake that you can just download and install directly on Linux that works with our Visual Studio support.
So, like, I'm assuming we're going to be compiling the program on the remote machine, right?
Yes.
Will the code completion get the system headers from the Linux?
Yes, it will. So if we go, the first time that you actually connect to that machine, it's going to pull down all of the system headers, anything installed from your system package manager, and as of Visual Studio 15.9, which is currently out in preview, it will also automatically detect any Vcpkg instances that you have installed on the machine and will pull down those headers as well. And with that, it also collects some details from the C and C++ compiler and toolchain, so it can give you a very accurate IntelliSense experience. It's pretty accurate to what would actually build. Yep.
Actually, there's various documentation on Vcpkg, including that dialog that seems to threaten some sort of Mac support. Is that
Yes.
a thing?
There is Mac support, yes. I'm not sure if this example here builds on it, but Vcpkg does support Mac.
Okay. Anything that I debug to Mac and whatnot? Is that a thing?
Let us know if it doesn't work.
That doesn't sound fun.
We have not spent much time testing this with Macs. You can set up a Mac with SSH support, and our connection manager can connect to a Mac with SSH. The last time I tried it, because the Mac doesn't have GCC and it has a version of Clang that pretends to be GCC, what wound up happening the last time I tried this, but this was not with our CMake support, it was with our solution-based thing where MS Build is driving the compile. And in that case, it doesn't work on a Mac because some of the flags that we're emitting just get confused on the Mac, so our project base does not work there. I've not tried this. I don't know if this works on the Mac or not. We've been really focused on Linux.
Yep.
So this doesn't work with via an SSH gateway, and if you could add that support, I'm sure a lot of people would use it.
It doesn't work with what SSH gateway?
Gateways.
Via SSH gateway.
Yeah.
Oh, okay.
Yeah.
Good to know.
Sorry.
Yeah, a lot of people will definitely start using it. Right? Okay.
Yeah.
Windows remote Windows machine.
Not yet. We don't support remote building on a remote Windows machine yet, but that is something that we are looking into. Okay. So this should be configured. So let's build this. And this is going to be building on that VM that I was showing you earlier. Okay. All right. So let's try to run it. And if it does what I'm expecting it to, it's actually not going to work. It crashed. But don't worry. If you can see, it might be a little bit hard. The line that it's crashing on, nothing's gone wrong. It's actually trapped in GDB, and that error has been brought back into the IDE on Windows. It was trying to create a window here, and it failed because we haven't told it which display to use. If you're debugging a command line, you don't need to configure any of this, but if you are using some kind of GUI program that you'd like to debug, just log in here real quick, you just need to tell it which display you're using. So if I do get the display on here, it depends a little bit on which distro you're using, and for Ubuntu even which version of the distro you're using, so it does sometimes pay to actually go check what it is with that echo display. And then to configure that, just right-click on our CMake list.txt, debug and launch settings for Pong, and I'll drop this in here. This is a lot of text, but you don't have to change too much of it. Okay, of course, my clipboard didn't transfer over there, but that's easy enough. Okay. So if we do that now, I'm going to stick another breakpoint down here real quick. Okay. Try to start this up again. And that settings file that I just showed you there, the right-click debug and launch settings, if you wanted to send an argument, for instance, to your debuggy, that's where you would do that as well. So we should be connected to the debugger here. And if I lose, okay, so we have hit our breakpoint. Almost all of the debugger functionality that you would normally get on Windows, it works just fine with GDB. For instance, we can see it's pulling in all of our variables, all of our
File sort for this? Visualization.
Yes, that works. So you can use the NatVis files with this as well.
It also works with pretty printing. If you have pretty printing built into the binaries on Linux that support the GDB modes to render the different variables and stuff, we can support pretty printing as well.
Do you support, I think, core dumps remotely?
I can't remember if we enabled core dumps in Visual Studio. I don't think so. I know that you can open a core dump in VS Code. We should be, it's on our backlog. I don't think we got it off the backlog. But it is possible with the underlying support that we have for GDB to open core dumps. And I know we did it for VS Code, but I don't think we did it in VS yet.
Yeah.
How does it work through GDB server, right? GDB server.
I think it can support GDB itself just by piping commands to it. It also has support for GDB server. It depends, I think, on how you configure that debug
That's right.
file.
How it's managed to target on the remote side? Through SSH or the service?
Oh, it's through the SSH connection. Everything runs through a tunnel.
Right?
Without what?
Tunneling. It's you can make a connection go through SSH.
If we're invoking GDB directly on the remote, it's over SSH and then GDB is invoked there. If it's GDB server, I believe that it's just a GDB server that we're connected directly to. I don't believe that we're doing GDB server over SSH. I'd have to check on that. I know that we definitely do GDB server directly, especially for embedded scenarios.
So one other thing that we can do here with the debugger is we can control the instruction pointer. I did just lose, so let's fix that. All right, and let's play. Oh, hey, I won. Okay, great. So, you know, if you can't cheat at Pong, what's the point of having all this cross-platform tooling? So, gonna stop that before it blows up in my face. So, one of the other things that I wanted to show here is now that we actually have this configured with both our Windows configuration and our Linux configuration, if I edit the code here, let's say I want to create a place to store my high scores with this Pong program. If I try to do something like mkdir, give it a name, you might notice it has some purple squiggles under it. What that's indicating is because we've set up both of these configurations, the Windows configuration and the Linux configuration, it knows that this mkdir method that I'm using here, it is supported on Linux, but if we go over here to Windows, this doesn't exist. So if we go look at where this is defined, so if we just do a quick go to definition here, it's coming from stat.h, and again, I apologize for the tiny text here, but this is actually coming out of the Linux header cache. So this is the stat.h that actually came off of my VM, and that's how we're able to provide this IntelliSense experience that's accurate to the build. And then if we go back to the x86 debug, it's telling us that file doesn't matter anymore. If we actually look at this sys.stat, on Windows this doesn't really do the same thing, so it just defines a couple data types and a few other files. So the cool thing about this, these purple squiggles is they can actually give you a heads up if you've done something that isn't necessarily cross-platform. When you're working on these projects, you're not necessarily always doing this with cross-platform in mind. You might be have your head in the game and writing some code for trying to solve a specific problem, and you're not necessarily thinking about, well, maybe this isn't going to work on Windows, or maybe this isn't going to work on Linux. And you don't necessarily find that out until you've actually checked it in, and your CI server comes back and says, no, this doesn't actually build. If you have it actually configured in Visual Studio with your Linux and Windows configuration, it can warn you up front that something is wrong, and while your head's actually in the space of the feature that you're working on, of bug you're fixing, you can fix it right then and there to use either an ifdef to use the right API calls that are platform specific, or hopefully just find another alternative API that works across both platforms. So that was most of what I wanted to show here, so I'll hand it back to Mark to wrap it up. And one thing, I showed a lot of this was all based on CMake, but what Mark's about to show you is pretty much all of these features that I've demonstrated, they work even with other build systems as well. So if you have Makefile, or if you're building everything with Python, your own custom build logic, it's fairly straightforward to get all of this working in Visual Studio as well. You just need to do a little bit more configuration.
Yeah, a lot of it works even if you don't know how to build a project, which I'll actually show. So to kind of wrap up, I mean, this is what you just saw. Is you saw using Vcpkg on Windows and Linux to acquire a library. We saw actually we didn't show VS Code editing on Linux. Ron showed that in her talk that's been recorded. If we have time, I'll show that. But you also saw that CMake with no platform-specific switches, it built that same CMake file built on Linux and it built on Windows. You also saw us using CMake to target both Windows and Linux, Visual Studio debug both Windows and Linux, and the Visual Studio platform-specific IntelliSense. And I think to that point, how many of you who are doing cross-platform development, do you test on any, when you're working, do you test on anything other than your host before you check in?
Oh yeah.
Congratulations to the few of you that are doing that. How many of you rely on your CI system to do that for you? Oh God, I knew it. I'm so not surprised by that answer. And I guess some people raise their hands both times, right? I think, yeah, both times. So, what happens when those tests fail? And actually, how many of you think, when you have that, where you're relying on your CI system, how many times is it something like what Will showed, where it's something where that header, you didn't realize that header did something else on that other platform? Do you think that IntelliSense specific to that, those purple squiggles would help you catch things before you checked in?
Yeah.
All right, good. Yeah, so to be clear, those purple squiggles, you don't have to actually build for that to work. If you're building just on Windows, you can make a connection to a Linux machine that's configured for your build to get all of your headers and everything down, and you can configure that support for connecting to that remote Linux system. It doesn't require that you actually build there. You could actually just stay there working in Windows and just notice those purple squiggles when they're showing up to catch some errors before you actually commit them. So you don't have to actually build to get that support. Yes?
Is it possible to specify that a file should only be for Linux and another file should only be for Windows? So if you do need platform-specific code, you may want to put it in separate source files and include them that way. And then you know ahead of time that those smoothly wouldn't apply.
That would be true, yes. So the question was if you have different source files for specific platforms and maybe you're using ifdefs or defines to switch between those. Or project settings, yes. Yeah, that would help you know that you can ignore them in some cases.
And
yeah.
Are you able to specify that this file should only apply to Linux?
I think I don't know. I think the ifdefs would highlight to you that it's not CMake. Yeah.
If you have a conditional in your CMake list and you are and you're including a source file only on a specific platform, if you select in that drop-down a platform that file doesn't apply to, VS will warn you. So it knows which files are applying to which platforms based on the logic that's actually in the CMake list itself.
Will it properly highlight the pieces of code if I use ifdef, say ifdef Win32 or something?
Yes.
Like changing the platform will properly highlight.
Yeah, I believe so. Yeah, I haven't used ifdefs a lot lately, but yes.
So you guys compile to basically build IntelliSense.
We generate the CMake cache to support the IntelliSense. So the CMake cache generation doesn't require a full build. But it does need to generate the CMake cache in order to support the IntelliSense there. Now there's IntelliSense can also be provided without CMake by specifying includes and JSON files, and I'll show that in a second.
But I'm wondering, this example with MKD or vsync,
Mhm.
was it based on IntelliSense data or some sort of background compilation?
It was IntelliSense data from the CMake
Yes.
cache.
Yep.
Yeah. And yes.
Do the purple squiggles tell you which build configuration?
Yes.
Yeah, they do. The question was, do the purple squiggles show you which build configuration is at issue? And yes, they do. Yeah. So I think, hearing, the sort of, that it would not be uncommon for you to get a bug from your CI system that you have to then go investigate. Or worse, maybe it passed that and now you've got a runtime issue that you've got to investigate. What happens when that bug comes back to you and it's not on your platform, and I think that this is the thing that starts to happen, is that you start asking Windows devs to go fix something using GDB, and they have to go start Googling, how to start GDB and how to actually connect to a Linux system. But it's kind of similar in the sense that Linux devs are also unfamiliar with Windows tools like VS and debug, right? But we're going to focus on attached to process for Windows devs who don't have to learn to use the GDB. So let's see here. That is WSL. Where is my VM? Let's connect to this. Just go full screen.
That's not showing.
Oh, oops. Oh, I see. Sorry, I minimized PowerPoint. I thought that would do it, but no. It's got a special mode. How do I get out of that? In slideshow, there we go. All right. So actually, you maybe saw that Will didn't have copy-paste working from his VM. So I'll just quickly show you this. In newer versions of Windows, in Hyper-V, there is this VM quick create. You see this? All right, there we go. So you actually have a quick create for Ubuntu in here now, so you can create more than just a Windows VM through quick create in Hyper-V. If you use this quick create for Ubuntu right here, it's going to set this machine up so that copy-paste works, and it will set you up with RDP. So that it's just a much better experience than the standard, like creating an Ubuntu VM from an ISO. I just so highly recommend this. And so don't do it again. So we can see if I connect here. Go full screen. Come on. It's so great. So we'll come here and I'll show you a different program. I'm not going to show you Pong this time. How many people here have 3D printers? Oh, I expected more. How many of you guys who have 3D printers, how many of you use OpenSCAD? Yeah, okay, yeah, all right. So OpenSCAD, if you're not familiar with it, is a cross-platform program that lets you programmatically define models. So you write some scripts, and then this will generate 3D models through basically the scripts that you can then export as STL and open them in your 3D programs, or print them out or whatever. The thing about this program is that it's cross-platform. It uses something called MXE. So it builds. Oh, really? Uh-oh. I better go faster. So this program, I built this on Linux. So it's actually a CMake. It's got CMake list.txt in there, but it's actually CMake. So that kind of confuses Visual Studio if I try and open that directly. So I built this just directly on Linux, but I'd like to be able to debug it. So if I go over to Visual Studio, I've got this program open here, and what I did was in my CPP properties file, so you'll notice here there's no makefile or anything in here. This is just the source for OpenSCAD. So I just cloned this, and instead of opening the root where the CMake list.txt is, I went down into the source directory and opened that. And now Visual Studio has no idea what's going on. So I created this the CPP properties file, and I gave it a little bit of information. And so I told it to inherit a Linux environment, so it knows I'm using GCC. I told it what compiler flags I wanted to use and that sort of stuff. But I also told it this remote machine name. And so by telling it that remote machine name, what that is doing, if I come down here and look at some of my includes, and if I come down and find where string is, normally I have more screen space than this. Good to go. Yeah, I normally have a lot more screen spaces. There's string. All right, so if I open string, you can see that maybe it's a little more legible than from Will's, but not too much. What this is showing me is it's in the header cache for my remote Linux connection. But what if I didn't have that, and I come back over here, and if I get rid of this remote machine name, oops, and do that, then if I open string this time, and I hover over that again, what we see is now this header is coming from Visual Studio itself. So our Linux support comes with kind of a base set of headers of kind of a standard Linux system, but it's not specific to your system. So if you're not specifying a remote machine name or you haven't created a remote connection yet, you'll get some basic IntelliSense for Linux, but not specific to your machine. But in that case, what I want is the one for my actual remote machine. And so what I wanted to show you was attached process. You saw that I started that, oh, I'm even out of real estate to see. So you can see, I mean, I've got this app here, it's running, and this is the sort of thing that when you're asked to debug a cross-platform thing, especially if it's at runtime, and it's running on some other machine, and now it's like, well, you know, what's wrong with it? You're going to have to come over, and one of the things you'd want to do is attach to process, right? So you can come here into our attach to process dialog, and you can click SSH. And then I can choose a connection. So if you have multiple connections, you could have the one that you need. And so you can see here I've already specified to use native GDB code. And if I scan my processes, there's OpenSCAD, and so I can attach. Ah, okay. So what this is telling me is that basically what I'm trying to do is I'm trying to connect to this remote machine to another process that I didn't start. When we start debugging from Visual Studio, we're starting the process on the remote Linux machine, and Linux is more than happy to let us debug that process because we started it. In this case, we didn't start this process, and so Linux is not happy with us. So what we need to do is go back over to the remote machine, and we need to give it a command. Now that dialog box actually gives you a link to a help article that will tell you the command that you need. It looks like I've done a lot more since then, so why don't I just go to my history, and I will grab for... Oh, oops, yeah, thank you. So, and then I can bang, we'll do 866. All right, so that should be good after I elevate, so that should be good. So now we can try and attach again. That seems like a completely fair thing to prevent me from doing what I wanted to do in that case. That setting is not persistent across reboots, by the way, so anytime you reboot your machine, you'll have to rerun that. I'm not sure how to persist it, but now you can see we're actually in debug mode, but nothing's happening. We haven't hit a breakpoint. The program's not stopped. But if we come back over here, and in this case, I wanted to investigate something when I click New, and so that pops me right back into the Visual Studio debugger from attached to process. And now I'm a little bit short on time, but what I wanted to show you guys, so you can see here's some of our variables, you can see the call stack, and in the output window, you're seeing the output from debug. So this is the output from GDB coming into the output window, so you can see all of the symbols it's loaded, etc. We get asked sometimes by people who know GDB, well, I have a special GDB command I want to run. How can I do that? In Visual Studio, there's a command window, and what we have is it's hidden down here in other windows, so in the view, other windows, command window, and in there you can actually type debug.mingine. MIngine is the tool that actually bridges the Visual Studio debugger and GDB. It speaks the MI interface to GDB. And so there's this mi debug exec command, and so I can come in here and do something like info threads. And so you can see, so I brought back my threads, but of course I'm in Visual Studio. That may be great if I'm on Linux and TUI, but I'm in Visual Studio. So I want to come in here and look at my threads this way. And so you can see it's the same threads you've seen, so they're in a much better visualized view, right? So there's a lot more power to using Visual Studio here, and if I stop, what's nice is my process is still going. It didn't actually interfere with my process, right? So And I could reattach if I need to come back later and do some more. All right. So I don't think we're going to have time to show VS Code and editing on Linux, but so why don't we just pop back to the presentation for a moment and wrap this up. How many of you think you could use that? All right. You think that'd help you debug problems you run into a little more easily? Good.
Is it only in the professional or is it in the community?
It's in community. So, and I guess that's a good thing that we can highlight about. So everything we've shown you today in this talk about Visual Studio is in community. When you look at Visual Studio and the community and pro editions, there's not a difference between those editions and capabilities. They have exactly the same capabilities. The difference is in the license. So the license for Visual Studio Community limits it to individual use, to smaller companies, based on revenue, employee size, that sort of thing. Or if you're using it for open source projects, you should check the license for details on that. But that's the only difference between those two products. It's just a licensing difference. So what we showed you there was opening a folder of just source code, and we configured IntelliSense in Visual Studio. We didn't build it. We just configured it to use the headers from the remote machine that we were actually connected to. So we got IntelliSense specific to that machine. One thing I guess I forgot to show you, I had specified a bunch of more paths in that file that I didn't speak to. The way I figured out those additional paths, they were for Qt libraries that had been installed in a subdirectory. So they were referenced from the source code as though they were system libraries, but they were installed much more deeply than that. And if you look at the make file for OpenSCAD, you would find that they were actually specified in the include paths of the make file. So I went there and found those and got those there. The other thing I'll give you as a tip is that for OpenSCAD in particular, and I find this with open source projects not uncommon, is I really tried to use their docs to build a debug version of that. And I could not build a debug version. I had no symbols. I couldn't debug, and I spent way too much time following their instructions, trying to figure out how to get symbols, until I just realized I should just open the make file and change it to emit-g for the C compiler, and then I had my symbols, and I was happy with debugging. So you do need your symbols. So we showed you all of that. And so the last thing I kind of wanted to close on was, your host, where you're doing your cross-platform development. Is it helping you or is it hurting you? Or maybe neither, maybe you're just happy with it. And we kind of wanted to break out like some things that we see when you look at different hosts. And from one perspective, a common thing that they all have is all hosts generally, you can run a VM to run another OS, right? It doesn't matter what your host operating system is. Most of them allow cross-compiling in one form or another. But then when you start looking at shells, it starts to get a little more interesting, shells and package managers. In Linux, you've got Bash and many other variants. You can actually run PowerShell on Linux. How many of you knew that? All right, not uncommon knowledge, all right. So yeah, so you can run PowerShell on Linux. And you've got, of course, as we spoke about earlier, there's all sorts of package managers on Linux. Windows, you've got Bash, PowerShell, and CMD. And CMD, it's interesting, but there's actually investments being made these days in Windows 10 around CMD. And if you follow the Windows developer blogs, you'll see updates on new things that they're enabling for CMD. But when you're doing cross-platform, especially if you're doing Windows stuff, it's not uncommon to come across bat scripts and the like. So it's useful to have CMD, right, to understand what's going on there and to be able to run things. Windows also has the Windows subsystem for Linux. How many of you have seen that? How many of you used it? Okay, good. I'm glad to see that that's common knowledge. More and more distros are coming out for that, and they've even released tools that you can build your own distro if you have the desire to do so. But of course, Windows doesn't have a package manager. You can use Chocolatey, but of course for C++ developers, what you care about is your libraries, and so in that case, I hope you use Vcpkg. Mac has Bash, right? They don't have a package manager either. They've got a homebrew thing. I guess actually you could run PowerShell on Mac. I need to update that slide. You can run PowerShell there. I guess that's good for .NET stuff. But then finally, you've got containers. And the interesting thing is that Linux and Mac can run Linux containers, of course. Windows can actually run Linux and Windows containers. I haven't seen Windows containers support on anything other than Windows yet. Windows containers are a thing. How many people have used Windows containers? Okay, a few. How many of you have used MSVC in those Windows containers? No? Okay. We have a blog post up on the VC blog that explains how to actually get the MSVC build tools into a container so that you can use those there. So that's something that we're hopeful to see more of. So I guess with that, I'll leave it to you guys to draw your own conclusions about what might be a great host. Only one of them runs Visual Studio. They all run VS Code, but only one of them runs Visual Studio. So with that, I'll just close and remind you to take our survey and show up at Herb's talk tomorrow to find out who wins. Maybe it's you. And I think we're out of time, but we'll hang out for questions and show you any of the stuff that we didn't have time for.
Yeah, you can ask a question.
Oh, okay, we have time for questions? All right, well, okay, we do.
We have half an hour until the next session.
Oh, okay, great.
I don't have a question. It was very impressive, you guys. Well done.
Thank you.